mode.
Hello, welcome you all for the webinar organized by Aspiration Energy. So we thank everyone for the overwhelming response. So now we expect a few people to join us for the webinar, and till then you can watch the whiteboard videos which we have created for various applications. So once this is over, our CTO Satyanarayan will give up the presentation on the topic. Thank you so much. And I would. And for all the participants, there is a question tab there on the right hand side of your screen. So for any questions you have on this webinar, you can post it. And at the end of the webinar, it will be answered by Satyanarayan. Thank you so much.
This is Mr. John. He runs a busy canteen, but he is worried about his energy bills. Surveys indicate that energy spent for hot water consumption in canteen is a whopping 70%. Smart canteens have moved to solar energy for hot water generation, using traditional thermosiphon method. First, water is sent into storage tank, and from there water flows to solar collector. Again, the heated water is back to storage tank. From storage tank you can get hot water. However, these smart canteens are not fully happy with the thermosiphon model, because it does not maintain constant temperature throughout the day. This makes the arrangement messy and making some of them regret their decision. Are you worried as what is the solution to your soaring energy bills without compromising on your temperature requirements? Here comes the award-winning innovative solution from Aspiration Energy, forced circulation system.
How does it work and what's the difference?
Let me explain. To understand this, let's explain the issue with thermosiphon. Temperature is not constant in thermosiphon, but in forced system temperature is high and constant throughout the day. Now let's see how it works. Water is pumped into forced circulation system and it's been controlled by 3 valves, which supply water in constant temperature throughout the day. Water is pumped into solar collector. It's been controlled by 3 valves. Pump helps us make the water hot very fast. Heated water is collected in tank and it's connected to your kitchen. So, are you ready to save your energy bills? Then get ready to change your ordinary canteen into smart canteen. Thank you for watching our video. For more information, log on to www.aspirationenergy.com.
Hello everyone. Now I request Satya to take over.
Hello, good afternoon. Hope I am audible. I can hear some echo in the background. Okay. So thanks Deepa, thanks a lot, and I welcome you all to this interactive webinar on heat pumps. So the current topic of this webinar is 11 considerations. So basically, I presume some of you are here because you already heard about heat pumps and you're thinking about making it part of your green energy initiative. And some of you might be new to what's a heat pump. So I would like to briefly talk about what are some of the considerations that you should keep in mind before you go forward with your purchase. Let's begin with just first talking about what is a heat pump. So the number 11 or the consideration number 11 is that a heat pump is very similar to your chiller. So most of you are familiar with the industrial chillers or even the air conditioning unit that is utilized in our homes. So if you look at a heat pump, the behavior or the performance is similar. All the internal circuitry, everything that is used is similar. So the biggest difference comes from the utilization point. A chiller is typically used for the chilled water or the cool air output it produces. So we are essentially focusing on the evaporating temperature. So the utilization point for a chiller is the evaporator. Whereas a heat pump, we have switched the utilization point to the condenser. So essentially what we are trying to do here is utilize the heat available in the hot sink. So the cold sink, which is normally the place which is being cooled in case of a chiller, now supplies some amount of heat, and the balance of heat is made up by the electrical energy that's being pumped into the heat pump, and the entire thing is available to us as part of the energy that is usable. So in a way, your heat pump is something that amplifies your ambient solar energy and then gives you at a much higher temperature. Number 10 is that one of the considerations that you want to generally pay attention to is the temperature of hot water delivered by your heat pump. So normally, most of people who are very familiar with the refrigeration world talk about it in tons of refrigeration, and the ton of refrigeration is typically defined by the compressor size. So for example, when you say your heat pump is rated at 25 TR, that's essentially the evaporative load that is being provided by the chiller, but then the 25 TR is essentially something that is rated at a given condition. For example, in this particular chart for a Danfoss compressor, at a 5-degree evaporating temperature, the 25 TR is available to you when your hot water is delivered at about 45 degrees to 50 degrees. But when your application demands usage at about say 65 degrees as mentioned here, then essentially your chiller capacity is 20 TR and the available hot water actual capacity drops from about 31 TR at 50 degrees C to about 28 TR. So when you are considering buying a heat pump for satisfying your process needs, do pay attention to the actual heat required by your process and size it at the actual usage temperature as opposed to the nameplate rating of the compressor. Number 9, ambient temperature affects the performance or the electricity consumption of your heat pump. So it's from the first chart, it is clearly evident that some amount of electricity is consumed by the heat pump and a lot of ambient heat is extracted by the heat pump. Now you can imagine when I'm running a heat pump in Chennai or places that are quite hot, there's a lot of ambient heat available. This ambient heat can be from your room air. It can also be a water source like an underground well or a sump. So if the ambient heat is very low, most of your thermal energy output at the condenser side is made up by the electricity input. And as the temperature goes lower and lower, your heat pump becomes just another electric heater. Number 8, the realized electricity savings. So normally we are all used to the COP or the EER, energy efficiency ratio or coefficient of performance of heat pump systems. Typically a catalog or a user manual or the technical brochure of a heat pump contains COP, which only talks about the heat delivered by the heat pump divided by the overall electricity input. But your actual realized energy saving is something that is also taking into account all the auxiliaries. For example, this is a live or this was a recorded utilization graph from one of our installations that you can see the running energy consumption of the heat pump was around 6.5 to 7 kilowatt hour. But then when it's going to be about to be shut off, there is still about a small blip here, which is about 15 to 20% of the overall energy consumption, and that's taken up by circulating pumps. So in case you have a heat pump which is supplying to multiple number of processes or a process tank where this heat is being delivered, then you need to account the auxiliary consumption before you realize what will be the finally delivered electricity saved. Number 7, the rated COPs specified by the manufacturers are only a test condition. And this is something we are all very confused by, because the nameplate rating typically has something like this, where you see nominal performance and the ambient temperature is T0 and TC, which is the condensing temperature. And the COP is specified at that particular capacity. And typically the COP of a heat pump, when it is specified as a chiller, this is the same compressor that is used in a chiller, which is also used as a heat pump. So when you're using that, you simply have to add 1 to your COP of the air conditioning unit to derive the COP of the heat pump. But if you look at the graph on your left-hand side in this particular slide, you can see that as my evaporating temperature keeps changing, the COP significantly changes. And at about, say, even 5-degree evaporating temperature, and if I have a 65-degree condensing temperature, my COP is only about 2 here, or for a heat pump it's about 3. So though the nameplate rating is at a test condition, before we make our decision, we have to really see what is the actual performance in your utilization condition. Number 6, typically, as you saw in this heat pump, there is a hot side and a cold side. So you might be thinking, can I use both of them? Of course, you can use both of them, and in fact, it improves your energy efficiency significantly. But the challenge is you can only dedicate one side to be your primary side. For example, if your primary utilization is hot water, then your condenser becomes your primary side, which means whenever the heat pump is running to deliver, to cater to your load or deliver hot water, then you can take the benefit of your condensed evaporator to provide chilled water, and vice versa. You cannot make both of these as a primary load, in which case the operation of heat pump and load balancing becomes a significant challenge. Number 5, choice of refrigerant. So there are lots and lots of refrigerant available, and depending on the temperature that you want to use, depending on the efficiency of your system, and depending on the design of the heat pump, you can pick one. And you would probably be aware of large heat pump systems or manufacturers which work with ammonia as a system. For example, Emerson. And then there are also other heat pump manufacturers that typically use other refrigerants like R22, 407, 410A. What determines your outlet temperature or the process temperature is your choice of refrigerant. In our case, at Aspiration Energy, we use these 2 refrigerants, which is R134A and the new refrigerant, which is Opteon XP140. So what you see here is the maximum temperature that a system's refrigerant can reach, which means your hot water probably is about 5 degrees less than this when the heat pump is designed. And the restriction comes from typically the Pmax or the pressure. Essentially, your compressor can handle only so much pressure. So that's the challenge when you're using ammonia, or when you think about ammonia for a small system. The temperature, though technically it is possible, the commercial compressors available in the market cannot cater. So one of the primary limitation comes from the pressure. Hence, currently in the market, the maximum available temperatures are about 95, which is supplied by us, and then about 65, which is most commonly available through a lot of manufacturers. Number 4, though we looked at heat pump as a very complex or a new technology, it is something that you are all very familiar with. A chiller service engineer can actually service your heat pump. So if you look at the internal components of a heat pump, you can see here it's a Copeland, in this particular case, it's a Copeland scroll compressor, a tube-in tube heat exchanger, and all the accessories which you would normally find in any packaged industrial chiller. So it's as simple as that. So your though the utilization is different, but the technology is such that you have lots and lots of service engineers available. So your investment, if there is a problem, will never. If your investment, if there is a problem, you will never get into trouble for want of service. However, the consideration is number 3, where if you're thinking of integrating it into your existing process, the thermal engineering, piping, hydraulics, and controls, especially for industrial applications, becomes very critical. This, for example, is integration of heat pump into a pre-treatment process where there are multiple tanks, where it is required that the considerations of maintaining temperatures in the tank, load balancing, quality of water, and in any case spike in demand due to some unknown emergencies has to be taken care of. So integration is a big thing which you need to really pay attention to make sure that your heat pump operates at the best possible efficiency. Did you know that in this particular case, a poor design of a buffer tank can decrease the COP by more than 10%. So we normally think that we can take care of all the load effects and balancing by simply introducing a buffer tank. But then an oversized buffer tank essentially makes your heat pump run much more longer than what the process requires, and it can decrease your COP by as much as 10%, so directly affecting your energy saving. Number two, heat pumps are a great energy saving device. It gives you excellent paybacks and sometimes even less than 1 year. However, to achieve that, there are two factors. One is how much does your electricity cost, and the second one is how many hours do you run the heat pump. So this is an example of a typical application for a pre-treatment or a washing machine utilizing a heat pump, where you see a single shift of about 8 hours takes about 3 years for a payback, whereas a 3-shift system running for about entire 24 hours, the payback is less than 1 year. So when you're considering a solution, do keep in mind that heat pump, the more you run the heat pump, the faster you pay back. And finally, number one, the best return on investment is obtained through integrating with solar thermal. So we have done a lot of analysis to see what can deliver you the best cost of electricity or best cost of heat delivered. And one of the model is where you have a solar and a storage coupled to a heat pump, where there is a buffering by the storage and also solar caters during the sunshine hours. So in this case, the system, you can essentially replace your existing fossil fuel burner to run completely on clean energy. So with that, I would like to thank you for the participation, and I have probably run through a little quick. So I'm open for any questions, and then we can discuss whatever doubts you may have. Thank you. So the question I have received is, will heat pumps be useful for cooling applications, and will they be a real challenge to solar water heating applications? Question by Mr. Jaydeep Malavya. So like I said in my slide earlier, you can decide to see which one is your primary application, either heating or cooling. So heat pumps do offer a good payback and return on investment. People are looking only at payback of short term, but if you are looking at a lifetime cost of operation, say for example 20 years, solar thermal does offer a significant advantage, primarily because after your investment is paid back, the energy is practically free. Whereas even though your heat pump is highly efficient, it is still pegged to electricity consumption. So you have the challenge that every year your electricity consumption or the cost of electricity is increasing. So there is a point at which your heat pump is more expensive than solar thermal. I hope I answered your question, Mr. Jay. Okay, so I will go back to one of my previous slides. The question here is that what is the difference between a ground source, air source heat pump? So if I go back to my slide on the effects of ambient temperature, for example, if you look at a heat pump, there is this contribution by the ambient heat which runs the heat pump. So this ambient heat can be from a variety of sources. It can be the room where the air is sucked in through a small radiator into the heat pump. So in this particular model, you see there is a radiator on top of the heat pump which pulls in the air. So this is called as an air source heat pump, which means the heat is delivered by the air. In terms of a ground source heat pump, the evaporator side, the ambient heat is provided by a ground water or a coil or a pipeline drilled into the ground. So for example, in places like Leh or Ladakh, where the ambient temperature is very low, people use of ground source where they can drill a small borewell or they can drill a small hole which is about 200 to 250 feet and then take the heat from the ground to supply to the heat pump. So that becomes a very efficient source of utilizing heat. Excellent question by Mr. Nandakumar. What is the lowest temperature at which the ambient is 5 degrees or 0 degrees and you want hot water at 45 degrees? Yes, the heat pump will work. But if you want to work in a hill station where your ambient temperature is say minus 10 degrees, then we have to design it separately.
Satya, like this question for asked by Nandakumar, it was not audible to him. So can you please repeat it?
Sure. So the question was, what is the lowest temperature at which a heat pump can work? Whether is it possible to install at hill stations where the temperature is low? So yes, the answer is, it is definitely possible. It depends on the ambient temperature and the delivery temperature. For example, if you want to install at a hill station where the ambient temperature is 0 degrees or 5 degrees, and the delivery temperature required is 45 degrees for a hotel or hospital application, it will definitely work. But the challenge is when you want to install it at where the ambient temperature is say minus 10 or minus 15, then the heat pump and the compressor and everything has to be designed differently. Hello.
Like climate chamber, but I found the efficiency to be less. Why?
Sorry, can you repeat the question?
They had been using a heat pump in their laboratory for maintaining the room conditions, but the efficiency was less. So he's asking why.
So this is a question by Mr. Pravi. So to answer your question, we need to know what is if it was an air source heat pump, we need to understand what was the ambient temperature around the heat pump. So basically that determines your efficiency. If it, for example, you say it's a climate chamber and the ambient temperature around the heat pump was say about 15 degrees centigrade, and the delivery temperature you had been using is fairly high, then the efficiency will be proportionately lower.
Okay, and we have another question from Mr. Karunakar. What would be the investment for integrated solar system, which was mentioned in one of the slides?
So the typical investment depends on the application. So that is not generally what is called as it's specific case to case. So as a thumb rule, you can say a solar thermal EPC based solar thermal system will cost you about 30 to 35,000 rupees per kilowatt installed, and that can be converted to square meters. And a heat pump will also cost you around the same number, but the kilowatt rating of the heat pump will be slightly smaller than what is the solar system requirement.
Again, same question. Another question from Mr. Karunakar. If I need both hot water and cold water, what would be the possible temperatures?
Again, it is process specific. If your hot water requirement is of the order of 75 or 80 degrees, the cold water temperature will be around 15 to 20 degrees. Whereas if your hot water requirement is only about 50 to 55 degrees, the cold water temperature available will be around 5 degrees.
A question from Mr. Jaideep. Are the fluids biodegradable?
The fluids are standard refrigerants. So as much as a refrigerant that is biodegradable, but then they are not naturally occurring fluids like hydrocarbons or carbon dioxide or ammonia. So they are standard refrigerants which is used by our compressors and refrigerators. So they have to be handled as per the requirements.
Question from Mr. Abhijit. How to decide the capacity of a heat pump?
It depends on the process. For example, if your system currently has an installed electric heater for maintaining water temperature, what we normally suggest is to install an energy meter and monitor the kilowatt hour consumed for a period of about 1 week, including the daily load profile variation. And the heat pump capacity is designed by the maximum or the peak load that is typically found in your system. For example, if you have a washing machine that is consuming on average about 10 kilowatt hour of electricity, but then you have a few occasions where it peaks up during a routine operation to 12 or 14 kilowatt hour, the heat pump is typically designed for about that capacity.
We have a question from Narendran. Whether the heat pump can be used for cooling application or replacement of chillers?
It can be, like I said in my earlier slide, you can use only one as your primary. So if you think cooling is your primary requirement, you can use it as a primary, then hot water is only incidental. So you get hot water only when the cooling side is running. Whereas if you use it for heating, the cooling water is available only when the heating side or the heating load is available. So you can manage this situation by providing some kind of a buffer tank on either one of the sides, but then you have to consider what is your demand on both sides.
A question from Mr. Sridhar. What capacity to be selected to maintain at 50 plus or minus 5 degree?
So capacity is dependent on your current fuel or current electric heater that you are using. 50 plus or minus 5 will determine the delivery pressure of my heat pump. But then to determine the exact capacity of heat pump, I need to know how you are currently maintaining it. So how many liters of diesel or how many kilowatt hours of electricity you are consuming to currently maintain that system, based on which the capacity can be decided. Alternatively, you can give us the dimensions of the tank, saying this is the LBH of the tank and this is the open surface area of the top, and you can also provide us with the details of what are the components that is being dipped into the tank, then we will be able to say that what is the approximate capacity required.
This is further to the question asked by Mr. Praveen earlier. He says that it is an air source heat pump and it's in a Bangalore conditions.
Okay. And what is the delivery temperature that is being maintained in the heat pump?
That he has to...
Okay. So we will be glad to send one of our technicians to have a look and assess the situation as to why the performance is lower. But generally the primary reasons for low performances are, one is if there is a very big difference between the ambient temperature and the hot water delivery temperature. The second one, if there are lots of uninsulated lines around the from the hot water delivery of the heat pump to the utilization point. And the third one, if there are high capacity circulation pumps. And the fourth one is if there is a very large size buffer tank as opposed to the size of the rate of delivery of the heat pump, the buffer tank is oversized. So these are some of the reasons why the coefficient of performance of heat pump can drop. And the one more point is that if the evaporated chill air that is coming out of the heat pump does not have any way to get out of that zone and then it cools down the zone where the heat pump is present significantly, this will also affect the performance. So it is recommended that if the performance is low, one of the first things we try is to duct the cool air from the heat pump to an area where it does not affect the intake of the heat pump.
A question from Mr. Nandakumar. Okay. What is the difference between the lowest ambient and maximum delivery temperature? What will be the COP impact on that case?
So let's go back to this particular slide here. So for example, you can see the blue line here, which is evaporating temperature of 0 degrees centigrade, and my condensing temperature going all the way from 30 degrees to 60 degrees. Now you can see the COP impact. So when my condensing temperature is only 30 degrees centigrade and evaporating is 0, I have a COP of 5, which drops all the way to 2 when I still maintain my evaporating temperature of 0, but can increase my condensing temperature to 60. So this kind of provides the trend how the COP varies with both these temperatures.
Question from Mr. Praveen Kumar. Can we use the heat pump at all weather conditions for Delhi location or at Middle East where the temperatures are dependent on the season? And is it that selection of refrigerant plays an important role on designing the heat pump?
Yes. Yes and no. You can use the heat pump in all weather conditions provided you can guarantee a minimum evaporating temperature. For example, if there is a way by which during extreme winters the temperature to the evaporator or the evaporating side of the heat pump, just 1 second, let me pull up that slide. The evaporating temperature over the evaporator here is above the refrigerant temperature, the heat pump will work. So for example, in Dubai or Delhi conditions, if the winter temperature is going to go to 0, if there is a way where we can provide a water source, then there is no problem with the heat pump. And the second, what was the second question, Deepa? Deepa, what was the second question?
Second question is the selection of refrigerant important on designing the heat pump for say 45 degrees?
For a 45-degree delivery temperature application, selection of refrigerant is not very critical, except that it marginally affects the efficiency of heat pump. Selection of refrigerant becomes very critical when you start looking at a very high temperature application.
We have another question from Mr. Abhijit. What should be the ambient temperature required?
A recommended ambient temperature for a high COP of heat pump is above 5 degrees centigrade. So the question, Mr. Nandan, is what is the maximum lift, the difference between lowest and highest temperature? Here you can see in this particular graph, the maximum lift that I can provide is in this particular category of heat pump is between 0 degree and 60, which is a 30 degree lift. In the heat pump that we supply, the 95 degree heat pump, our lift is about 70 degrees is the maximum lift we can provide, from 70 degrees, from 20 degree ambient to about a 90 degree delivery temperature. So that is the maximum lift we can provide without significantly affecting the COP. So the question is, I heard the latest heat pump can have a COP of 7. Is that possible? Of course it's possible. If you look at the graph that I have here, for an evaporating temperature of 15 degrees C, if I look at 40 degrees C a delivery temperature, the COP of the chiller is 6. For the same heat pump, the COP of a heat pump would be 7. The purple line that you see in my graph right here. So it is possible, but then it is dependent on the delta, the temperature difference. So if you only require hot water for a hotel or shower applications and your ambient temperature is fairly high, you can get an extremely efficient system. But if you are focusing on industrial application where you want to go all the way even beyond 80 degrees C, then the COPs are much more modest.
Okay. Another question from Mr. Kishore. How much temperature can be taken as an output from the heat pump?
So the current best-in-class heat pump available for the highest temperature is 90 degree water on the small sizes. You can look at much larger heat pumps made by Emerson and all using ammonia and all that. Can go up to about 100, but then commercially available and the best in class heat pump is about 90, and mostly what is commonly available in the market is about 65.
Okay. Another question, like from Mr. Karunakar, what is the best possible COP for heat pumps? He has heard that the latest heat pumps can have the COP up to 7. Is it possible?
Okay, so I just answered that question. The best possible COP of a heat pump depends on multiple factors. Like I said here, you can see the graph that I am projecting right now. For example, this purple line where I use an evaporating temperature of 15 degrees and a condensing temperature of about 40 degrees. The COP of this particular chiller is about 6. And if I use the same chiller as a heat pump, my COP will be 7. So it is possible, but then it is dependent on your use case. So if you're going to use the heat pump for a 40 or 45 degree or a 50 degree application, then a COP of 7 is possible. So the next question is a 24 kilowatt load, 2000 liter water in a cooler at what temperature? Question by Mr. Sridhar. (45-degree) temperature. So for this case, I think we should be able to deliver a heat pump which is typically less than 10 kilowatt. Our 55. That's fine. I think for this case, we should be able to deliver a heat pump which is running at about 10 to 11 kilowatt. So your electricity consumption will be half of what you would normally consume.
Another question, if the temperature requirement is only 40 to 60 degrees, then what will be the refrigerant? Do we still offer R134A or Option XP140?
Option XP140 is only offered when your temperature is about 90 and above. For a normal less than 65 degrees C, the typical refrigerants are R407 or R410A. So the question by Mr. Chinni Krishnan is selection criteria and application areas. So the typical selection criteria is what are you currently using as a fuel to generate hot water. So for example, if you're using diesel or LPG or electricity or furnace oil, that's one of the places where you can find very attractive returns or SKU.
Satya, sorry to interrupt. Can you be a little louder because the phone audio is not clear to some people, it seems.
Okay. So the selection criteria and the application areas, question by Mr. Chinni Krishnan. The typical selection criteria are as follows. The first thing is what is your current fuel, either it is diesel, electricity, SKO or furnace oil. The second criteria is the temperature. For example, if you are using anything less than 90 degrees, so your heat demand is only less than 90 and you are using any of these expensive fuels, then it becomes an attractive choice. And then the third is typically the ambient, and most of it is all manageable, but the two biggest that impacts your payback are these two.
Another question from Mr. Balamurugan. The COP correlation graph, is it a manufacturer graph or obtained by case studies?
So this particular graph is a manufacturer graph. So we do have a similar graph which we generally generate after every application. So typically, if you see this particular slide, I have just pulled out the power. This is our online monitoring system. In the same set of data monitoring platform, we also have real-time COP measured. So we generally measure all the performance parameters of heat pump, and that's where my comment which says that the COP of the manufacturer is only for the heat pump, where it only talks about heat delivered by electricity consumed, but the overall system COP will also take into account all the other auxiliaries.
So now this question from Nandakumar. So our offering of heat pump for less than 65 degrees C will be with the R22 or 410A or 407C.
It will not be with R22. The new systems will not contain R22. It will be either with either one of those new refrigerants.
The question from Mr. Kamalakannan, what is the maintenance cost of heat pumps compared to electric heaters?
So typically the heat pump maintenance, if you look at the overall system here, let me just pull up that particular slide. The maintenance requirement of this heat pump is quarterly cleaning of all these evaporator tubes and this particular heat exchanger. So you can consider it as a one-man day operation. So about 1,500 rupees plus the cost of whatever cleaning chemicals. So about 2,000 rupees per quarter. Vis-a-vis electric heater, I think it is primarily just an on-off system, so you would not have much maintenance except some coil cleaning. So the heat pump is about 2,000 rupees per quarter is what you would normally expect if you were to do it yourself.
There is a question, sir, Satya. What is the lowest outdoor temperature at which the heat pumps can work efficiently?
So typically it also depends on your usage temperature. If you are using it for temperatures of 45 and 50 degrees, a heat pump can work efficiently even down to 0 degrees. But if you are using it for a 90-degree application, then the lowest outdoor temperature is about 15 degrees.
A question from Mr. Mayur. Which heat pump is more efficient, water source or air source?
It is dependent again. Air source, water source is typically more efficient because it provides you a much constant temperature. Also, it has a circulation pump which is more energy efficient as opposed to the fan of an evaporator. But if your air temperature is significantly higher than your water temperature, then air source heat pump can also become efficient. But generally, if your ambient air temperature and water temperature are similar, then water source heat pump is more efficient.
Question from Mr. Abhijit. What will be the highest output temperature achieved from a heat pump?
Highest water output temperature which can be achieved using our commercial heat pumps is about 90 degrees C, 90.
Another question, Satya. If we want to use the heat pumps, say in hill stations like Ooty, do we need to only use at daytime or even it can be used at night time?
Yeah, it can be used 24/7. There is no problem with it. It is driven by electricity. It can be used 24/7. The efficiency might slightly vary depending on your ambient temperature, but then nothing stops us from using the heat pump.
Question from Mr. Praveen. If temperature and both RH is critically to be maintained, if temperature and both RH is to be maintained critically, when which heat pump is recommended?
So it is heat pump is a system which only delivers the heat and the chilling for you. So the rest of the system design will have to be designed carefully to maintain temperature and RH. So heat pump is only part of that equation. So if it's required that you maintain a clean room or any such controlled ambient, then the whole system design has to be taken into care as opposed to looking only at the heat pump.
Question from Mr. Kamalakannan. What is the minimum kilowatt hour consumption required to get benefit from a heat pump?
It is again dependent on what is the smallest size heat pump economically available. Our current portfolio of products start from about 8 kilowatt rated capacity. So below that you don't have very efficient compressors and your cost of the heat pump becomes uneconomical. Even at 8 kilowatt it's uneconomical. So I would recommend anything about 10 kilowatt connected load is where your heat pump becomes a lot more efficient. Alternatively, if you have many such systems which are nearby located, which is progressively more than about 20-25 kilowatt, I mean cumulatively more than about 20-25 kilowatt, you can then have a single heat pump cater to all these loads.
Question from Mr. Abhijit. What are the daily critical parameters to be monitored for a heat pump?
So normally heat pump is like your outdoor unit in your AC. You don't worry about it much. So it typically runs and it is all an on-off system. So as a periodic maintenance practice, you would want to check the pressures. That is typically in this particular graph, you see there are like multiple gauges which tells you the health of the system to see if there is no leakages or anything else. And then periodically you might want to clean these fins and then see if there is a lot of puddling of water and clean the water. But otherwise, a heat pump is something which we normally run. What is more important is how you look at the integration itself. So based on our experience, what we have seen is that the quality of water in your process really determines and can contribute significantly to the behavior of your heat pump. So if, for example, this PS3 here is actually a strainer, and if the strainer is choked and you don't have enough water going through your loop, it can lead to a tripping of the heat pump. But then if you have a proper maintenance process laid down for your process tanks and the water is fairly clean, when I say clean, I'm not talking about all dissolved stuff, but I'm just talking about physical impurities, then the heat pump system does not really give you a trouble.
Question from Mr. Mayur. Which heat pump should we choose in order to achieve more efficiency? Vapor absorption heat pump or vapor compression one?
These are very different technologies. For example, when you say vapor absorption, you are essentially dealing with a thermally driven system. So if you can say, for example, estimate the cost of energy for your heat, say when I say solar driven vapor absorption system, the cost of solar heat is about 3 rupees per kilowatt hour. And if I convert it to the vapor absorption heat pump, the COP of that is about say 1.2 or 1.3. So essentially I'm talking about 2.5 rupees per kilowatt hour as my thermal cost. Whereas if I look at a vapor compression system, and if my cost of electricity is only about say 6 rupees or 6.5 rupees, then the cost of heat is about half of that. So it's about 3 rupees. But then the overall cost of my system itself is only 1/2 or 1/3 of my vapor absorption system. So you have to really look at the entire economics. Where vapor absorption system becomes a lot more effective is when you have a lot of what you call as waste heat, where you want to simply use your waste heat for your process.
Further to that, Mr. Mayur has a question that whether vapor absorption heat pumps are available in India.
Vapor absorption heat pumps are available, but they are primarily available for cooling. Thermax is one of the largest manufacturers which does vapor absorption system using lithium bromide. And they typically start at the fairly large 40-ton sizes, 40 ton and above. And there is another company called Bry Air which does vapor adsorption, the AD adsorption systems. They are also available for waste heat to cooling, and they start at about 10 tons.
A question from Ajay, is heat pump safe for cooking applications? Is there any chance of leakage of refrigerants during exchange?
There has not been an issue of that. Heat pumps are fairly safe. You can run, people do use it for hot water applications for canteens and also for bathing. And the leakage of refrigerant into water, the chance of that is very, very small. And even otherwise, these are not classified as very toxic. These are not classified as toxic refrigerants.
A question from Mr. Abhijit. Is there any parallel option for heat pump?
I'm not sure I got that question very. I understood the question clearly. When you say a parallel option, you're talking about multiple heat pumps in parallel. Is that correct?
He is asking about whether there are any parallel technology available. Sorry, sir. I'm sorry, Satya. He is meaning the same. Like, is there any parallel connection?
Yes, heat pump can be connected in parallel, definitely. In fact, one of the projects that we are currently working on for which the schematic that you see on screen is a parallel connection of 5 heat pumps of different capacity. So if you do your thermal engineering, piping and hydraulics accurately, you can connect any number in parallel.
Question from Mr. Kamalakannan. What is the maximum distance between heat pump and the process tank? What is the heat loss?
So we would recommend it to be not more than 100 or 150 meters max, because the heat loss is of the order of about 10 to 12 watts per meter length of pipe after insulation.
Question from Mr. Sridhar. Is the size of the tank related to the capacity of the heat pump?
Absolutely. So the size of the tank is related to the production rate of the heat pump. So, and the number of exchanges, if you look at this particular diagram here, the number of exchanges that happens between the heat pump and the buffer tank and between the buffer tank and the process. So if you oversize the tank, my heat pump is on a lot more. And if I undersize the tank, then the process is not satisfied accurately. So it is important that we size the tank appropriately, giving in some specific buffer.
Another question from Mr. Mayur. Can vapor absorption system be used as a heat pump as well as chiller? Heat pump as well as chiller.
So typically a vapor absorption system utilizes the heat available and converts it to cooling. So you can use, for example, if you have a 120-degree waste heat, the vapor absorption system will provide you about a 7-degree chilled water and a 50-degree reject water. So you can utilize the 50-degree reject water as your heat source and your 7-degree chilled water as your cooling source. But as it is primarily designed to upgrade your wasted heat to cooling.
And is there any such systems available in India?
The vapor absorption systems are available through Thermax. Thermax sells these VAM machines, so it is available. Yes.
Question from Mr. Abhijit, like besides AHU, what are the other applications of heat pump?
Currently, we are not utilizing heat pumps for air handling unit. We are specifically utilizing heat pumps for hot water supply to industrial processes, like in the automotive, the 7-tank process, or in other applications like pharma, where you can supply hot water at about 50, 60, 70 degrees centigrade. The other commercial application of heat pump is in the hotels and hospitals industry, where you can supply the guest room water. Currently, every guest room might have an electrical geyser, or there might be a common diesel boiler that is supplying hot water to your customer. So these places, a heat pump can replace those geysers or the diesel boilers.
A question from Mr. Kishore. Is the total system available in the market readily, or it is customer design is based on the customer's need?
So typically the heat pump is available in standard size packages like 14, 28, 56 or 65 and all that. The rest of the integration is customer specific. We also offer pre-integrated skids. At Aspiration Energy, we offer pre-integrated skids for whatever the heat pump sizes that we offer. So basically we offer 2 skids. One is the heat pump skid and the other one is the balance of plant skid. So the customer will simply have to just plug in the tubes and then they will be ready to operate.
Thank you, audience, for attending the webinar. Is there any other question? We have another 5 minutes. A question from Mr. Nandakumar. Do we need to use the balancing valve as well for heat pump?
So the balancing valve at what location? So we normally don't, once the heat pump is internally, once it's designed and set, we don't normally disturb the heat pump. And the rest of the process is through our process integration. So we don't normally disturb the heat pump, it's just an on-off system.
He's saying it's the pipeline, the balancing valve.
Here the balancing valve in the pipeline, okay, here it is specifically done when we commission the system, just to make sure the total kilowatt delivered to each of the process is appropriate. For example, a single heat pump is delivering to 3 or 4 different processes, and each of which has a different kilowatt rating. So in order to cater to each of that, we have a balancing valve which is set at the commissioning point, after which it is not modified.
Question from Mr. Ajay, like, can a better or more efficient compressor be used? Now it's a scroll compressor which is being used.
So there are 2 technology options. One is a scroll compressor which is available in the smaller size ranges, and then you have a screw compressor. So screw compressor driven heat pumps are slightly expensive, but they are available and can be used beyond a certain size. These are the 2 most leading technologies currently available, and then the innovation from Copeland or Bitzer have made them the most effective choice as of now. For the smallest size heat pumps, we tend to use reciprocating compressors.
Another question from Mr. Mayur. Why there is so much of variation in COPs of heat pumps from different manufacturers?
So typically it depends on their choice of compressor and depends on their specifically choice of compressor and the other system they have. So for example, the biggest contributor to a heat pump efficiency is what is called as the polytropic efficiency of your compressor. So how efficient is it in compressing the refrigerant vapor? So if you use a reciprocating compressor, you can expect an efficiency of about 55 to 60%. And scroll compressors can go up to about 65%. Screw compressors can go up to about 70-75%. So depending on the choice of refrigerant, the choice of compressor, and the choice of motor, what is driving the compressor, efficiencies can vary. So it all finally boils down to your cost. It's kind of a trade-off. So, but as of now, if you look, a lot of heat pumps are more or less similar. So it will only be decimal point variation between one and the other.
Mr. Mayur further asked that, like, which will be the most efficient type of compressor for any heat pump?
So if you were to go for the absolute most efficient compressor, will be a BLDC compressor. Currently Toshiba and Panasonic are trying to develop certain compressors based on BLDC motor. The same that now are becoming popular in our homes as inverter ACs. But then these BLDC systems are not yet designed to offer very high temperature. So you get about 65 degrees as the maximum delivery temperature. So in those ranges we do get these compressors, but then the cost is almost double. So if I say that the current heat pump is about, say, 100 rupees per kilowatt, the other heat pump is about 200 rupees. So it's almost double.
And Mr. Praveen Kumar has a question that whether the reciprocating compressor or centrifugal compressor, which is better?
So centrifugal compressors, Mr. Praveen, is available for fairly large heat pumps. When you talk about hundreds of tons. So in those capacities, centrifugal systems are very excellent because your turbine blades and everything is large, so your fluid mechanics offers you excellent efficiency. But when you start coming down to sizes of tens of kilowatts, centrifugal machines are very, very poor in operation. And they also have a very big challenge that whenever there is a droplet in your system, like liquid droplets in your refrigerant, they tend to damage your compressor blades. So you cannot find centrifugal compressor driven heat pumps at very small capacities. Large ones, hundreds of tons, you might be able to find them.
Question from Mr. Karunakar. Would you recommend heat pump over chiller for chilled water requirement at 6 to 8 degrees C where cost of electricity is around 6 rupees per kilowatt hour, how much would be the difference in investment between the two?
So it again depends. If you also require hot water as a side process benefit, I would say you can combine the two. But if you only want a chiller, then there is no need to replace the chiller with a heat pump because they are pretty much identical. But if you have a requirement where you also need hot water, then you can cut down your expenses by more than 50%. Now, because since you are using both the chiller and the hot water, now your COPs can be of the order of 4, which means for every unit of electricity you spend, you get 4 units of thermal energy output. So that is how we look at it. So if you are only interested in a chiller, then I think you might be just better off if you run the chiller as it is.
Question from Mr. Ajay, like can heat pump be used in drying process like food packaging?
It can definitely be used, and it's one of the more promising applications because drying requires control of humidity and control of temperature to less than 55 degrees. So if we have a heat pump which can deliver hot air at about 50-55 degrees and control humidity, it can be used for drying.
Question from Mr. Abhijit, what type of compressor would you recommend for a commercial heat pump application?
So as of now, if the recommendations on compressor is dependent on the tonnage of heat pump, so up to a 25-30 ton capacity, the recommended compressor is a straw compressor, beyond which we tend to look at screw compressors.
Question from Mr. Ajay, like can we provide a solution for drying groundnut before making it oil?
We would be able to. We would definitely be able to provide solution for groundnut.
Dear participants, like we have a couple of minutes left for concluding this session. So we can take 2 to 3 questions. Question from Mr. Kamalakannan, like 36 kilowatt electric heater for 1400 liter tank capacity, 24 hours operation and 45 to 50 degree temperature to be maintained. What is the recommended heat pump capacity?
So I can only say based on our experience, if 36 kilowatt is the rated capacity of the electric heater, typically the system will be running at about 22 to 24 kilowatt on a load basis. So we would recommend around a 28 kilowatt heat pump max. But the actual sizing is better done if we couple it with an energy meter and determine what is the load, actually running load consumed on a daily basis. So that will allow us to size the heat pump more accurately. But then as a thumb rule, if you can say that about 60 to 70% of your rated capacity will be the heat pump sizing.
Question from Mr. Nandakumar, in drying process, do we need to introduce an air handler along with heat pump?
So there are specialized heat pumps which we offer for drying process, which will integrate the air handler and the hot air delivery system. So basically it's a closed loop system which will pick up the air laden with moisture, pass it through the evaporator coil where it will drop out the moisture and then pass it through the condenser coil and it will heat the air again and then it goes through the drying system. So it's like a closed loop system that can be provided to be integrated with a small drying chamber.
Question from Mr. Rajai, like what applications are there in the tire manufacturing industry?
So tire manufacturing, typically what I have seen is they do some kind of profile heating where they have different temperatures at which they have to maintain the process, and which is currently being catered mostly using steam. So I'm not absolutely aware of where heat pump is directly applicable, but wherever you require temperatures of less than 90 degrees, say about 50 to 80 degrees, can be catered using heat pump. But from what I've seen in Thailand, they do also have certain cycles where the temperature goes beyond 100. So I have to study those sectors in detail to be able to answer. Alternatively, if you have some process examples, we will be able to help you with the sizing.
Satya, Mr. Abhijit wants to know what aspiration energy is into.
Aspiration energy, as you can see, our tagline here, fast forward to the solar future. So we primarily work on two technologies which will take us to the future. One is solar thermal, which is integrated into the rooftops, basically catering to process load and process heating requirement of less than 120 degrees C temperature. And then we also do heat pumps, which is, we call it as passive solar because a lot of heat is taken from the ambient and catering up to 90 degrees C. So we have the ability to do direct integration with your process without disturbing any of the existing systems, and do complete remote monitoring of all the process parameters, and also bill the customer on the energy delivered basis as opposed to a capex basis. So these are three of our biggest trends. So we do solar thermal, which is rooftop. We do heat pumps, which is up to 90-95 degrees centigrade, and we do billing of heat. So we provide heat as a service. That's something that you can simply derive from.
Question from Mr. Mayur: how can we get in touch with you for future requirements for heating solutions?
Oh, right there. You can write to us. You can call us. We are always available, and we'll be happy to talk to you and help you out with any needs you have.
Thank you all for attending the webinar. Hope this webinar was useful to all of you. We plan to conduct more webinars on various topics, and you'll be getting regular invites from us to attend the webinar. And as far as today's webinar is concerned, the whatever questions are asked and the presentation, everything is recorded, and it will be uploaded in YouTube, and the link will be shared with you. So I once again thank you all for attending the webinar. Have a great weekend.
Thanks a lot for the time and participation, and we look forward to your comments. If you have any questions or any feedback about the webinar, I will be really happy to